Some of the topologies, or some of the layouts of our networks, and the physical, of course, we can go right back to the original type of physical connection we had was a bus. A bus is where everybody is connected in basically one long line. It's sort of like having a water pipe go down the street and everybody connects to that one water main. That's exactly, of course, how our original networks were set up. We might have a thick net or a thin net cable snaking around the office and everybody connected to that one cable. You might still have at home an old 4-port hub, and with that you could connect everybody, all 4 people could connect to that one hub, and all of the traffic that you sent was then received by all of the other devices. What would happen in that case is that each device, when it saw a packet come in, would read the address and say, oh, is this addressed to me? If it is, it would accept it. But if it wasn't, of course, it would just drop it and say, oh, it's not for me, I'll ignore it. Now, that is where, of course, a administrator could set then their NIC card, network interface card, into what we called promiscuous mode, which meant that they would capture all of the traffic going to everybody. This would allow an administrator to be able to then see all of the traffic and see if there are any issues or problems on the network. But a bus type of assembly used a lot in our early mainframes and early networks and so on has really been replaced for the most part today by what we call star networks and so on. A star is where everybody has their own Cat5e cable that comes to their desktop that goes back to one central switch. And everybody has their own port on that switch. And what the switch does is then it takes traffic that's going from one laptop and will then send it to the port associated with the other laptop, its destination. So instead of everybody getting the traffic for everybody, it gets routed directly just to its proper recipient. One of the things necessary for this is what we talked about earlier, though. This is where you then had to have things like ARP, address resolution, so the switch knew which IP addresses were associated with which MAC addresses. Now, the advantage of a star, it's very scalable. You can add on more devices and so on. In fact, quite often we'd connect several stars together into what we then call a tree. But the star itself, the switch, was, of course, a single point of failure. One of the early types of communications we had within a local area network was like token ring. And token ring was one of those products you either really liked or you really didn't like at all. And with token ring, all of the devices were connected in one ring. So the traffic went around that ring to everybody around the room. And you would look at it, is this for me? Nope, pass it on. And sort of like that game we'd play hot potato, where you pass things around very quickly from one person to the next. Now, the idea with a ring, of course, is that it was also what we called a deterministic level of traffic flow. The ring controlled traffic so that everybody had an equal chance to speak at a certain rate. And that in many ways was very efficient. We use rings today for things like fiber rings and backbones within a city and between cities, where we have a ring that all of the devices and all of the switching centers in an area are connected together. And this ring provides a fiber backbone that all of our traffic then flows on. And very resilient, and of course quite often with redundancy as well. Some of the devices that, of course, we've had over the years, we've had hubs, which would just cross-connect everybody, as we said, into a bus. And then when we had to send a signal too far down the road, we would put in a repeater. Because of attenuation, because of the deterioration in signal quality, when we sent a digital signal, it would get to a repeater, and what a repeater would do would be completely regenerate that signal. So it would take the incoming signal, figure out, okay, what are the bits, and then recreate those and pass them on. The idea behind a repeater was that then we generated a completely new, clean signal. And that meant we could quite often clear out any type of noise or other problems that may have happened as that signal transmitted across the cable. We mentioned switches, very often used in a star type of course, network. And the idea of a switch, as we said, was instead of sending traffic to everybody, we'd only send it then to the desired destination. And these are the core of most of our local area networks today. Now, the problem with the term switch is this. You see, switch is kind of a generic term. It's like saying truck. What's a truck? Well, a truck could be anything from a SUV 4x4 to a panel truck to, of course, a 18-wheel transport trailer. And switch is kind of the same thing. We have layer 2 switches, layer 3 switches, layer 4 switches. So different switches have different functionality. The core thing is they allow us to communicate between different ports, between different devices. And they route that traffic very often very quickly between those points. And depending on the type of switch it is, would also then determine the level of functionality and what it does as well. We also have routers, or if you're of course in the United Kingdom, you call them routers. The idea of a router is kind of like a traffic circle or a roundabout. You come into, for example, you're driving down a road and you come to a traffic circle that you've got maybe 4 or 5 different roads that go off of that circle. It's kind of like an intersection, but in a circle instead of just lights. And the idea, of course, is that you take which one is the best road towards your destination. And how do you determine what is the best road? The shortest? The fastest? Yeah, look for the traffic flows that are on it. And routers are very good because they allow us then to divert our traffic off towards its destination. We're allowed to take a look then at the header and say, if my traffic has to go there, what's the best way right now to get there? And routers use things like routing information protocol, border gateway protocol, open shortest path first. All of these are different protocols they use to try to learn what is the best way to route traffic, of course, to a destination. We also have gateways. A gateway is something that operates then at the perimeter of our network, where we have, just like a gate through a fence, we have the ability to monitor and in some cases prohibit or allow data to go through that perimeter gateway. We have things like application gateways. If you're doing voice over IP, you very often have a VoIP gateway that will allow you then to interface between your internal network and then the external. And the gateway serves as a point where the guards can stand and watch to make sure it's the correct type of traffic and so on before they'll allow it through then that gateway. Now, another term that's very generic is the term a firewall. What's a firewall? Well, firewalls, there's many different generations. A firewall can be anything from a packet switching router to, of course, then stateful inspection, to things like then a proxy, to, of course, the idea of next generation firewalls and so on. Now, so in other words, it's a very generic term that means actually a number of different technologies. But the idea for us as auditors is we want to make sure that whatever devices are being used within our organization, they're properly configured, they're properly managed, we're checking the logs on them so we know what's happening. We've tested them to make sure their rules are correct. And the idea of a firewall is that separation between two networks. And we put firewalls, obviously, between the untrusted internet and our internal network. That's one place of putting a firewall. And the one thing to remember is that the purpose of a firewall is to protect one network from another. So therefore, I can protect my internal network from an attack from outside. But on the other hand, I should also be watching any traffic that's going out of my network. Traffic that's going out of my network, is it possibly being used to attack somebody outside? Well, a firewall rule should check both ways. both to protect me from being attacked, but also to protect the world out there from somebody within my company attacking out against someone else. And the idea of a firewall is, of course, what is its level or depth of inspection? Does it really look deep into the packet? We often call this deep packet inspection. To really see, is there something in there that is malicious? And we can filter according to services, ports, protocols. For example, do we allow UDP traffic? Are we going to allow an ICMP packet, for example? And quite often with a firewall, we'll filter out and say, nah. You take, for example, you can ping Microsoft.com and it'll never reply. Their firewall just quite simply says, no, I'm not going to reply to that. You can, for example, and to many organizations, they won't allow something like unsolicited UDP traffic. No. If we don't have a record of somebody asking for this information, then we're not going to accept it. And so we also can filter according to addresses. We will not accept anything from this address, or we won't accept anything going to that address. These are all some of the rules we can put in firewalls. Or, of course, we may block certain ports. For example, all mail should come in on port 25, SMTP. Internet traffic going to our browser should come in on port 80. If it's an SSL TLS connection, port 443. If it's DNS, it should be on port 53. But things that we don't necessarily want, we then will block as well. Maybe we're not going to accept, should we say, things like FTP or Telnet traffic. So we can be blocking ports like 20, 21, 22, for example. We also have the idea of a proxy. A proxy is an intermediary, somebody that stands in between two people. And the idea being that if you want to go and talk to a famous person, very often you can't. You get to talk to their publicist. And their publicist, you go and say, I'd like to ask this famous person this question. And the publicist goes, oh, hang on, I'll get your response. They go get a response and bring it back to you. They're operating as a proxy. Now we have a number of different types of proxies. We have circuit level proxies such as, SOX proxies. And we also have application level proxies that can really examine our traffic, and especially used in things like web applications, to make sure that any traffic that's going to our web application has been thoroughly examined to make sure it's safe before we pass it on to the application in behind. We quite often will set up a secure connection across the internet. The internet, by its very nature, is insecure. People can watch other people's traffic. And so we want to go back to what we had years ago when we called them private networks or leased lines. We want to have a network for our own use. And even though this is going across a packet switch network, it's going to almost be as if it was our own little circuit, our own little private line. And we'll call these, therefore, virtual private networks. Now, a virtual private network is therefore a tunnel that we carve through the internet to carry our traffic. The internet being an untrusted network, we create a tunnel that our traffic will take. Now, there are different types of tunnels, and usually when we use the term VPN, we mean an encrypted tunnel. It's not always the case. There are several tunnels that are not encrypted, such as L2TP, a point-to-point tunneling protocol, for example. But usually, of course, we're talking here about an encrypted tunnel that all of my traffic will go down this pipe. Nobody else can use that private network we've set up, and nobody else can see it because it's encrypted. And where this is used a lot, of course, is with you're working from home as a teleworker, you're communicating with business partners, you're sharing information which is sensitive. You allow then remote access through the internet, but in a way that at least nobody else is going to be able to, one, see your data or in any way interfere with it either. One of the ways this is done is using Internet Protocol Security, or IPsec. And IPsec will allow us then at the network layer to set up this type of a tunnel so we can then communicate remotely and not have to worry about somebody then being able to then either see or alter my traffic.